Okay, so the first thing I want to mention is that quiz which you did on Wednesday. I have put up handwritten solutions on Teams. I handed them back to you on Wednesday. Um, Now, you may have found you didn't do very well on the quiz, and that's totally fine. It's very normal when you start doing exam questions to get less than 50%, even at the end of the year. So the first time you do a practice exam, at the end of the year, you'll probably get less than 50%, but with lots of practice, you're going to get better. So it's only up from here, okay? But I just want you to know what you're aiming for at the end of the year, and the bar is pretty high. So you do need to put in the work. So on Teams, you will go to Files, and when this page loads, there'll be a folder called Quizzes. Yep. So please make sure that you download this. It's this file here. So let me talk just very briefly about the quiz. All right, so with this question, won't be able to see that in the recording, will they? So if I do this, we'll be good. All right. So let's go back to the data. Normally, when you decide whether a data set is positively or negatively skewed, you want a box plot or a snake. So with something like this, do you think the picture will look like this or like this? Why do you say the first one, Tim? So what I want you to do is to match the data that was given to you in the first question to the shape. So the vertical scale is frequency. And then the horizontal scale will be teeth. Do we have more teeth in the lower values or the higher values? The lower values, okay. So does that mean it's negatively or positively skewed? Why? Why does it mean it's positively skewed?
Because of larger range.
Very good. So there is a larger spread, that is to say a lower frequency in the upper values or the positive direction. So for that reason, even though the frequency is higher in the negative direction, the spread is larger in the positive direction, and we define that to be positively skewed. Okay? So I reckon most of the class got this question wrong. So something that I think I may test you on next week. Okay? All right, question 2. Do I want to say anything here? No, question 2 was done well. Most people were able to say it was the median. Question 3. A common error was to say that the maximum was here. Now, when you calculate the maximum in your data set, you need to include the outliers. Because normally we want to throw away the outliers, right? But in terms of defining the minimum and maximum of the data set, you include outliers. So if you knew that, you would get question 3 correct. Question 4, this one was not done as well. Did we do box plots in Head Start week? I don't think so, right? So I know I did them in year 11 with you, but not all of you were here for year 11. So just to remind you, this is a box plot with no outliers. And the smallest value will be the minimum. The largest value will be the maximum. What's the middle line? Median. So if you did your holiday homework, you would notice. And what about these two lines on the box plot? Q1 and Q3. Okay, so it's one thing to calculate these numbers or to read them off the graph, but we also want to have an interpretation. So what percentage, approximately, will be between Q1 and the median? The median is also called Q2. What does the word quartile sound like? Quarter? 25%. Okay, so 25% between the first quartile and the median, 25% between the median and Q3, and 25% that way, and 25% that way. So if I give you this, now you should be able to answer question 4. Okay? So I've set that in the quiz solutions as well. All right. My advice for a question like this is if you're not comfortable trying to find the quartiles by hand, which I will go through in another lesson, you could actually just type this data into your CAS calculator and let it draw the box plot for you. Okay, and there would be a free mark for you. But do you know how to draw a box plot on your CAS? Okay, if you don't, that's probably because you didn't do the holiday homework. So you need to catch up on that. The mode has the highest frequency, so some people didn't seem to know what the word modal meant. Modal just means mode. Part B was all right. Part C was not done very well. There were a few issues here. So one issue was converting the number 30 divided by 180 to a percentage. So if you've got a fraction and you want to change it to a percentage, you need to multiply by 100 and put a percent sign on. And then the question also asks you to round to one decimal place. So I had quite a few people give me 16.3, which tells me that you know what you're doing. You just need to make sure you do the rounding correctly. A lot of people just wrote down a number. And if you did that, I probably wrote on the quiz, please show working. Because it's very easy to make a mistake in a calculation like this. If you actually write down your working, it'll be easier for you to spot a mistake, which you know your answers, and you're less likely to make mistakes as well. So I strongly recommend that you don't just write down the answer for a simple question like this, but you actually just show a little bit of working, because it's going to help you in the long run. Okay, and then question 2, in the short answer section, part A was done all right. Remember that the range is the maximum minus the minimum. So some people wrote 10 for the range because there's 10 values from 0 to 9 or 70 to 79. But we just want to take the difference between the highest and lowest values. And then part B, this was done well if you knew what the interquartile range is. So going back to this diagram, what's our definition for the interquartile range? Q3 take Q1. We did this last year. And then we need to define the condition under which data is considered an outlier. So it's either going to be above something or it's going to be below something. And that's when you get these dots out the front. So if my data is above a certain value, it'll be an outlier. If my data is below a certain value, it'll also be an outlier. But what is that something? Say it again, Tim.
More than 25%?
No. No. The definition involves the interquartile range. It was in the holiday homework. Well, I'm going to write it down for you now. So there are two conditions. You can meet either of these conditions. One condition is you are above Q3 plus 1.5 times IQR. Does that look familiar to you now if you were in my class last year? Yes. So you are expected to know this. They test this almost every year in this subject. So I expect you to know that. On the SAC, I will probably put a question about this on. All right, and today is all about the normal distribution. So I could tell that most of you did not do the pre-reading. That's all right, we'll go through it now. Do you have any questions about the quiz? As you finished the quiz last week, I could see if some of you looked a little bit stressed. I'd rather that you feel the stress now than at the end of the year. So I'm going to keep giving you exam questions every couple of weeks so that you know what you're in for at the end of the year and there's no big surprises. But you can do this and you are going to get better. When is the next quiz? Wednesday next week. So it's going to cover all of chapter 1, including the material that we do today. All right, and then after that, chapter 2 in about 2 weeks. So please make every effort to stay up to date. All right, so what I will ask you to do now is to turn to the handout that I gave. We're going to work through this handout, and then once we're done with that, I'll let you work on some textbook questions. If you can't, oh yes, Harry. Yes. Okay, when I'm sitting here, am I blocking the screen?
Yeah.
So if I stand here, is it better?
Maybe check on the
Okay, see how this goes. I can't scroll. If I do this, it'll work. All right, we'll just wait for Harry, and then we'll get started. All right, year 12s. So, have you heard of the normal distribution before in any context? Do you know where, Kaylin? You might have heard about it. Do any of you do psychology? Have you talked about shapes, different kinds of distributions of data or shapes? So, has Bron ever mentioned a normal distribution?
We did hold a sleep at one point last year.
Okay. Yeah, that's fine. So, in my opinion, if you go on and do maths or statistics or science at university, you will undoubtedly see this again. The normal distribution is probably the most well-studied thing in statistics because it appears everywhere. So if I had a very large group of people and I measured things like their height, or I measured things like their weight, or if I set an exam, what will often happen is you'll get a curve that looks like this. It has a very famous bell-shaped curve. So people will call this either a bell curve or a normal distribution. They're talking about the same thing. Your study scores follow a normal distribution. IQ tests, they follow a normal distribution. I'm pretty sure in sports, things like reaction times, there'll be a normal distribution there. So I am very confident that no matter where you go after school, there will be some application for this, even if you aren't aware of it. So all we want to do in this class is do some very simple calculations involving the normal distribution. We're not going to derive any of the theory, and I'm not going to prove any of the results. The method students get to do that at the end of the year. So, to describe a normal distribution, we need two pieces of information. The first piece of information is the mean. Now, if I was dealing with a numerical variable x, what symbol could I use for the mean of x? It's actually on the sheet. So x with a line above. That's the mean. Okay? Remember, if you put a horizontal line above the letter, that means the mean of that variable. All right, and then the other piece of information is the standard deviation. You don't need to worry about what that means. The standard deviation for our purposes is just a number that tells us how spread out the data is. And we are going to give that piece of information the letter S. Now, you'll see here, I've actually written the letter X to the bottom right. The reason is because later in the course, we'll have two numerical variables. We'll have X and we'll have Y, and we will want to distinguish between whether we're talking about the standard deviation of X or the standard deviation of Y. So if I just use the letter S, it's a bit ambiguous. But if I put the letter X here, it's very clear that I'm talking about X. So I want you to do that too. And the formula sheet that you'll be given on the exam will have the letter X there. But your textbook does not put it there, it just uses the letter S. Yes, Caleb? You get a formula sheet in the exam, but it is almost useless. That's my personal opinion. Because, I might as well just show it to you. Because why not, right? It won't help you very much, the formula sheet. Okay, that's all you get, guys. That's all you get. For a whole year's worth of content, yeah. Yes. So really, your formula sheet is in your bound reference that you bring in. So today, we're actually going to use this very first formula, the standardized score, and you'll see they've got X bar and SX there. Okay? And we've got this as well, the upper and lower fence of a box plot, the 1.5 IQR thing. All right, let's go back. Tim, Kaylin, can you finish your conversation? Okay, so before we do some calculations, I just want to show you what happens when we change the mean or when we change the standard deviation. So have a look at this first picture here. There are three curves, one in blue, orange, and green. They are different normal distributions. But the only difference is the mean. I've kept the standard deviation the same. So what do you think the mean is? Like what's changing here visually? Right. So the mean is actually in the middle of the curve. So this is the first one for blue. This is the second one. It's actually quite hard to draw a straight line here. And third one. Can you see that these are just copies of each other in different positions? Yeah. So that's what happens when you change the mean. Okay? When I change the mean, I'm sliding it to the left or to the right, nothing else. That's what the mean's about. The mean defines the middle of the normal distribution. Okay, now let's look at the second graph now. This time I've kept the mean the same, but this time I've changed the standard deviation. What's happening now in the picture? Take a careful look at the box here. Can you read that? Okay, so which graph has the largest standard deviation? The green one. And what do you notice in comparison to the other two curves? It's the most spread out. Okay? So the higher your standard deviation, you can write this down if you want. The higher the standard deviation, the larger the spread. All right, so let's recap. I've introduced this new thing called the normal distribution, and we're going to use two statistics to describe a normal distribution. Number one, the mean, which is the middle, and number two, the standard deviation, which is how spread out it is. Are we okay with that? All right, let's keep going then. All right, so this topic is all about this rule here. By the time we're done today, you will probably memorize this. You'll memorize the numbers 68, 95, and 99.7. Okay, so I'm going to read out the rule for you, and then we're going to do some calculations together. So this is what this rule says. If I have any normal distribution, it doesn't matter what the mean is or the standard deviation is. Approximately 68% will be within one standard deviation from the mean. So let me draw a diagram for you. So let's imagine I've got standard deviation of 5 and a mean. Let's pick a number. Let's pick 20. Okay. So the rule states if I start from the mean and go out up to one standard deviation, so you come to one standard deviation where it's 15 or 25, then just adding 5 or minusing 5 each way, 68%. If I go up to 30, so now 2 times 5 is 10, 20 plus 10 is 30, so now I'm 2 standard deviations away. It'll be 95%. And lastly, if I go 3 standard deviations away, sorry that they're not to scale. So 3 times 5 is 15. So now, if I go from 5 to 35, it will be 99.7%. But there is nothing special about the numbers 20 and 5. I could have chosen any number. Okay? So if you give me any normal distribution, I will always get these 3 numbers, 68, 95, 99.7. What do you think? This is one of the more difficult topics in this course. So I think it will make more sense if we do a few examples. Yes, Tim?
This wasn't a holiday homework, I'm not mistaken. Despite reading the book, I had no idea what was going on. So are we going to be covering that more?
The holiday homework?
That specific topic, the 98.
Yeah, this is, we're doing this today. Today. The whole double is about this. Okay? So don't panic. All right. So let's do example number 3 together. So you got the 68, 95, 99.7% rule in the box above. It will help you to write down the mean and the standard deviation and to use these symbols. So what's the mean? 67. And standard deviation? I would suggest you write this down, that you start every normal distribution calculation by doing this. This will make your life a million times easier. Okay. So some of you will see this straight away. Some of you, it might take a bit longer. That's fine. What do I need to do to get the 68% interval? 1 from 67. So what are the numbers going to be? Does everyone follow that? We started at 67 and we added 1 because we need to add 1 standard deviation. Here we started at 67 and minus 1 because we needed to go down 1 standard deviation. So if I go back to this picture here, what Taylor has done is we've got 67 in the middle, and she said to get 68%, we need to add 1 standard deviation and we need to subtract 1 standard deviation. Yes, Tim?
So the standard deviation was like 20, we will be adding and taking away 20?
Very good. Okay, so it'll be 47 and 87. All right, think you can fill in the next one? What do you think? How many standard deviations do I need to go away? 2. Okay. So what numbers? 65 and 69. It's this question is easy because standard deviation is 1. So I'm going to write 67 plus 2. The reason why I'm adding 2 is because I'm adding 2 standard deviations, and the standard deviation is 1.
Are you ever being 1, 2, and 3, will it ever have 4 by itself?
No, so you will only do 1, 2, and 3, and then there'll be various combinations between them, which I'll get to on the next couple of pages. All right. Can I just say 64 and 70? Okay. You're very quiet, and sometimes I don't know whether that's because I've lost you or you're just really, really bored.
It's just been a long week.
Yes, I'm sure it has been a long week, and it is a lot to take in as a Year 12 student, so I do understand. Okay, let's look at example 4. This is exactly the same as the previous question with different numbers. So actually, I'm going to stop talking. I'm going to give you 1 minute to have a go at this example. If you've done the pre-reading, then you can just work through the sheet and start the textbook work. And if you finish the textbook work, just start chapter 2. Don't let me hold you up. Okay? So 1 minute to attempt example number 4. And if you're done, just keep going with whatever you wish.
Just constant stress.
All right, guys, let's bring it back. So let's start with the 68% case. When I'm dealing with 68%, how many standard deviations do I need to go away from the mean? 1 standard deviation. So what should I do? What number should I add or subtract? 4. Because the standard deviation, Sx, is 4, and the mean is 158. Now, your textbook will do this. They'll say, go 1 standard deviation above the mean and 1 standard deviation below the mean. But I suspect that these symbols might confuse some of you, so I've decided not to teach it that way. Okay, so what you want to do is start at 158 and add 4. And here you want to subtract 4. All right, so it's 154 to 162. Pardon?
When you were learning math as a child, did you like understand it straight away, or did it take you?
No, it took time. Yeah.
So you went back
This took time. That's why I've given a whole double for this topic. I haven't given it 1 period. Yeah. Okay, second case. Now we're looking at the 95% case. So what number should I add or subtract this time? 8. Because 2 times 4 gives me 8. All right, and for the 99.7% case, how many standard deviations? 3. So what number should I add or subtract? 12. Now that we've done a couple of examples, is it making a little bit more sense? Yeah. Okay. Can we keep going?
Yeah.
All right. Okay. What on earth is going on here? Look at all these funky symbols. All right. So you will remember previously I said that the 68, 95, 99.7% rule holds for any normal distribution. It doesn't matter what the mean or the standard deviation is. One of the things we want to do is compare different distributions. So people sometimes call this standardization. I want a way to capture something like this. So let's see. Okay. Guys, have a look up here. Are you comfortable with me saying that the number 75 is one standard deviation above 70? Similarly, the number 36 is one standard deviation above 30.
Yes.
Okay? So even though these two distributions are the same, I want to be able to say these two are similar somehow. So the way we're going to do this is I'm going to convert everything to the same normal distribution with this will eventually make sense. It might not make sense initially. I'm not gonna use Z. That might confuse you. Yeah. Okay. This last one, the mean is 0, the standard deviation is 1. Are you comfortable with me saying that the number 1 is one standard deviation above 0?
Yeah.
Okay, so all these three distributions are the same. When we use what we're going to talk about, standardized values in a moment, we are really talking about this picture, this last one. That probably doesn't make sense, does it? All right, let's do some calculations and then maybe we'll come back to this. Yeah. Please remind me to go back to that last page. Okay. So I've introduced the z-score, the standardized value. I'm going to try to explain what it means. Let's look at example number 5. The mean is 67 and the standard deviation is 1. I think you can do that now. All right. Let's see what happens when I take different values. So let's imagine I reached out into the bag and I pulled out a tennis ball with a diameter of 64 millimeters. Every time I get a new tennis ball, my value x is going to change. Okay? So let's chuck the number 64 into this formula. Z equals x minus x bar divided by sx. What do I get if I evaluate that fraction?
So I think I can start.
You don't need a calculator for this.
You could
Yeah,
add
minus 3.
-3. Okay. I've got the explanation now. How many standard deviations away is 64 from 67? It's 3 standard deviations away. Is it above or below?
Below, so it's negative.
Yeah, that's what the z value is about. I forgot.
That's what
Okay. All right, let's see what happens. The number 65. How many standard deviations is 65 away from 67? It's 2 standard deviations away. Is it above or below? It's below. We're expecting this to be -2, all right? But let's see what happens. 65, x, because now it's a different tennis ball, minus 67 divided by 1 is -2. So if you go back to the box, please highlight, bold, put love hearts, whatever you want, because this is really what Z's about. Okay? So the word above indicates that if Z is negative, then X is below X bar. Okay, I'll leave it to you to fill out the whole table. Let's just do the very last one. Okay, so the mean is 67, the standard deviation is 1. So if I pull out a tennis ball with a diameter of 70 millimeters, what's the value of x I'm going to use? 70. All right, z equals x minus x bar, 67, divided by the standard deviation, which is 1. And 70 minus 67 is 3. How many standard deviations is 70 away from 67? 3. Okay, so that's what the z value is about. Okay, I'm going to take a poll of the class. Can you give me a thumbs up if you're good to try another example on your own with different numbers? This, if you're okay, but you need a bit more practice. And this, if you are, alarm bells are ringing and you're struggling. Okay. All right, so what I'll do, guys, is I will say I want you to do 150, 164, and 164.55. I'll give you a couple of minutes. This is example number 6 on the next page.
Just curious. In the formula, Z equals x take away the mean. But yeah, is it always going to be x take away the mean?
Yes, you must put it in that order or you will get the wrong answer. This will get, it will be, the sign will be flipped.
Will it ever be like x plus?
You must use that one.
Okay, as I walked around the room, it looked good. So the mean is 158, the standard deviation is 4. If I pull out a random person with a height of 150, the standardized score will be 150 minus 158 divided by 4. And if you evaluate that, you will get minus 2. But let's think about this. How many standard deviations is 150 away from 158? 2. And 2 times 4 is 8. And it's below 158. So I'm expecting a negative number. Okay? When you do this calculation, it should make sense. Alright, so spoiler warning. Alright, something interesting happens here. We don't get 1, 2, or 3. Right? Because if you try to calculate z, you'll get 164 minus 158 divided by 4. And 164 minus 158 is actually 6. 6 is not a multiple of 4, and that's fine. We're going to write a decimal number for this answer, 1.5. Okay? I will never ask you what percentage lie 1.5 standard deviations from the mean, but I am just saying I can be 1 standard deviation away from the mean or 1.5 standard deviations away from the mean. That's totally possible. Okay. All right, and if you do this one, do I dare try to do the maths? 1.625 and 6375. That was risky. All right. Okay.
Do you want us to round it or just not?
So if I don't tell you to round, it's fine.
Because I'm going to round it.
Yeah. It'll always be crystal clear in an assessment what I want. Okay? So because this is not an assessment, it doesn't really matter. Yeah. Okay, I think we're nearly at the end. We're nearly there. Okay. So take a moment to process this. Imagine I gave you a normal distribution and I turned it into Z. Okay? This rule is exactly the same as the first box, but this time I'm just using Z values. Remember, Z is the number of standard deviations which X is above X bar. All right, so minus 1 is 1 standard deviation below the mean, and 1, Z equals 1, I should say, is 1 standard deviation above the mean. So between minus 1 and 1, I'll get 68%. Between minus 2 and 2, I'll get 95%. Between minus 3 and 3, I'll get 99.7%. These numbers are the same. Okay? So, in a moment, we're going to put it all together. We're going to combine the 68, 95, 99.7% rule,
and the Z values to do some calculations together. And the reason why I've chosen to teach it this way is because I think it will make life easier for you, not harder.
All right. Please turn the page.
Now have a look at these numbers here.
Do you see the number 68 anywhere?
No. I mean, if you add them.
If you add the two 34s together, you get 68. What's 13.5 plus 13.5? 27. 27 plus 68. So I might write this here. 34 times 2 is 68. 13.5 times 2 is 27. 27 plus 68 is 95. Okay, so this diagram, it looks a bit different because I made this one myself. It's basically the same. So this diagram, you don't need to understand where it comes from, but you know the 68, 95, 99.7% rule. This diagram just shows what happens if I want something that's like between, what if I just want between 0 and 1 instead of -1 and 1? Because the 68% rule only tells me between -1 and 1. If I want between something like -1 and 2, I have to combine these three rectangles here. Okay? But it's hard if I only know these three numbers. I think this is best illustrated with an example. So let's do an example. Have people filled out this page already?
Yeah.
All right, well, let's do this one together then. Okay. You don't even need to add numbers up. So what percentage is above z equals 0? It's 50. Why is it 50? It's symmetrical. Okay? So by symmetry, 50% lie above 0. Remember? Oh, I didn't say that, did I? I didn't say at the beginning that the normal distribution is symmetric. I don't think I said that. It's symmetric. Okay. Okay. What numbers should I add together to get the percentage with z values between 0 and 2?
34, 13.5.
Right, so these two numbers here. So 34% plus 13.5% is 47.5, which is half of 95. Right, because it's only one half of between -2 and 2. All right, so I've filled out the table for you in example number 7. I'm only going to do one question on the last page because I feel that I've been talking for a very long time and I want to give you a chance to start doing some questions. So let's finish with example number 9 on the very last page. If you're feeling confident, you are free to start the textbook work whenever you wish. So let's start, and I want you to notice the way that I show my working out for this, because I think it'll make it easier for you as well. To do this question, I'm going to use a z value. How do I calculate the z value? Great. Yeah. Okay. I need a value for x bar, the mean, and sx, the standard deviation. Do I have that? Yep. So x bar is 158. Standard deviation is 4. So z equals, well, I need I need x as well.
150.
Yeah, just make sure you're reading it correctly. Why should I use x equals 166 here? Yeah, it's the height of a person that I'm giving you. So if I use 166, I get 166 minus 158 divided by 4, which is 2. Now, I want the height of everyone taller than 166. So can you translate that into a z value statement for me? Let me go back to the other. So I think now it might make a bit more sense now what I'm trying to do. So 158, 166, 0, 2. So this is x bar. This is z. X bar is 158. Sx equals 4. So this is 2 standard deviations away from the mean. So can you see, when I'm asking how many people or what percentage of people are taller than 166, it's the same as asking what percentage have a z value greater than 2. Is that okay? So let's go back now to the normal distribution curve. Which rectangles should I use here? I want z larger than 2 because I want x larger than 166. .5 is correct because this is 2 here and I want everything larger than 2. So I'm going to use this region of my normal distribution. So I'm going to add up 2.35 and 0.15 to get 2.5%. I don't know about you, but I feel that this is noticeably harder than last year, this topic. So I've got some good news for you. No other topic in this course relies on the normal distribution. The normal distribution is this isolated topic at the end of one variable data. So next week, we will not need this ever again.
Oh, perfect.
Okay?
Now, we'll be on now.
Yes, you'll probably get 2 or 3 questions on this. I would say it's unlikely that this is on the SAC because this is such a small part of the course. If I put it on the SAC, it'd be 1 mark, probably.
Will it be on the quiz?
Yes. This is definitely on the quiz next week.
Alrighty.
Okay. We've got half an hour left. I'm sorry that it went for so long, but it does take a while to understand this topic. So I'm going to leave it up to you now to get started on 1H. I will also start checking your holiday homework as well. I won't check everyone today, there's not enough time. But please have your holiday homework ready to show me. And off you go. Thank you for your attention.